write down the letter that represents each of the following. That is 2.1. And 2.1.1, we are looking for the letter that represents an alcohol. So let's go ahead and take a look at the options that we have. A is clear to see because we have the structures, right? And then C, it's also clear to see what is happening because we have the actual name. Same is true with D. Even though we don't have the actual name, we have the molecular formula, we can sort of work out what is happening. But there is an issue here with E, F, and H. It's really confusing to see what is happening when they are written like that. So it's better, before we even answer any question, we actually draw those structures so that we can see what is happening, and then it is going to help us as we answer our questions, I'm assuming. So let's go ahead and do that. First of all, let's start with E, right? So E, we have CH3, so we're going to have a carbon and 3 hydrogens, followed by, okay, we have a carbon there, and then in brackets we have CH3. Because it says CH3, it obviously has to be a branch, because it cannot be a carbon that is bonded to other carbons and has 3 hydrogens bonded to itself also. It is actually impossible. So we have a carbon that acts as a branch, and then it's actually 2 and not 1 because of these 2 outside there. So that is that part. And then as we proceed, we have a carbon followed by 3 carbons, right? So let's say 1, 2, and then the third carbon has 3 hydrogens, so that is 1, 2, 3. But as we look at these 2 carbons, we need 4 bonds, right? Because we know that a hydrogen is not a hydrogen but a carbon. It's supposed to accommodate 4 bonds. So let's see how that can be true. There's no other hydrogen left, so clearly there has to be multiple bonds between these carbons, right? So they all have 1, 2 bonds, right? So in order for it to be 4, this will be the third one, and this will be the fourth. So this is the molecular formula of compound E. Let's do the same for compound F and H. Right, so let me just erase 2.1.1 here and draw F and H. So F, we start with CH3, so that is C and then H3, right? And then we are followed by a carbon bonded to 2 oxygens. So obviously we know what is happening here. We're going to have 1 oxygen bonded to the carbon like that, and then another oxygen in that fission. Here we have an ester, it seems like. And then we have CH2 with 2 on the outside. So what does that mean? C, 2 hydrogens, another carbon, 2 hydrogens. If it was CH3, it was going to be a branch, because it is impossible to have CH2 to have CH3 as a carbon in the longest carbon chain. It has to be a branch. So there we go. That is CH2 and with that 2 on the outside. And lastly, we have this carbon with 3 hydrogens. That is F. So we have E, F, and lastly, let's do H. It seems like a painful exercise, but it is really important for us to do this, right? More especially when we have these kind of formulas that we usually don't see. So H, a carbon with 3 hydrogens. So there we go. And then we have a carbon, and then we have CH3 with the 2 on the outside. So those have to be branches because they cannot be in our longest chain. So 1 carbon, 3 hydrogens, 1 carbon, 3 hydrogens, and then followed by a carbon, 1, 2 hydrogens, carbon, 1, 2, 3. So that is E, F, and H. It is going to be easy for us to see what is happening as we move forward. So back to the question 2.1.1, we are looking for an alcohol. So A is clearly not an alcohol, B is not an alcohol, C is not an alcohol, but D can be an alcohol. Let's take a look at it and see if it makes sense. For D, we have C4H10 oxygen, right? So what is the molecular formula? Not the molecular formula, but the general formula rather of alcohol. We have CnH 2n plus 1 OH. So let's see how many hydrogens we're going to have if we have 4 carbons. So if we have C4, we're going to have 2 multiplied by 4 plus 1, that is 9 OH. Clearly, this is C4H10 oxygen. So the answer to 2.1.1 is D. it's easy to see now that that is actually an alcohol. And then 2.1.2, a compound with a 4-methyl group. So ketone, right, is carbonyl. It's carbonyl group, right? And then aldehyde is 4-methyl. So we are looking for aldehyde here. Which letter represents an aldehyde? It's easy to see that it is A there, because we have the carbon double bonded to the oxygen at the end of the chain. So 2.1.2, we have A as our answer. What about 2.1.3? An unsaturated compound. Unsaturated, we have multiple bonds, right? And then look at E, F, and H. Should be easy to see here that the answer is actually E, right? It's easy to see now because we actually have the structure. You can see the multiple bonds causing it to be unsaturated. If we didn't draw it out, it was gonna be a bit difficult for us to see. But then because we actually have the structure, it becomes a little bit more simple. So this is E, and let's do 2.2. So 2.2.1, we're looking for the IUPAC name of compound B. Right, so first things first, we need the longest carbon chain, right? So let's see. 1, 2, 3, 4, 5, 6. If we go down, we're gonna have 1, 2, 3, 4, 5. So clearly, going up, that's where we have our longest chain. So let me just circle these. Let me just circle this so that we can have a bit of clarity. This is our longest carbon chain. So now we need to decide where we are going to start numbering. Do we start numbering from the top, or do we start numbering from the bottom? Let's see what is happening. What is happening? If we start numbering from the right, we're going to have 2 branches on the third carbon, right? We're going to have 1, 2. We're going to have those 2 branches on the third carbon. But if we start numbering from the top, we're going to have these 2 branches on the third carbon, right? So here, because we are faced with this case, we are going to use alphabetical order, because whether we start from the left or we start from, whether we start from the right or we start from the top, we're going to end up reaching our branch at the third carbon, and both those branches we actually have 2, right? So here the priority will be alphabetical order. Okay, so bromo comes before methyl, right? So we must start with bromo, therefore. So this is gonna be 1, 2, 3, 4, 5, 6. So we have those branches, bromo on the third carbon. So 3.3 dash dibromo dash. So the methyl, it's on the 4th carbon, right? So 4.4 dash dimethylhexane, because like we said, we have 6 carbons on the longest chain. So hexane. So there we go. That is the IUPAC name of compound B. And then the IUPAC name of compound E. Compound E, we have the structure up here. So let me just see if I can actually drag this structure. Okay, I thought it was not working the way I wanted to. Come on, let's go down. Okay, let me just copy it and see if I can maybe paste it here. Okay, there we go. So this is the structure of compound E. Obviously here we have a functional group, right? So we have to start numbering our carbons from the side closest to the functional group. So this is going to be the first carbon, second, third, fourth, fifth, right? This is our longest carbon chain. Even if we go up, we're going to end up having 5 carbons on our longest chain. So that is pent 2YNE. Okay, we know that for sure. Pent 2YNE. And then we have branches on the 4th carbon. So we're going to have 4.4 dash dimethyl pent 2YNE. Right, so there we go. That is the IUPAC name of compound E. 4.4 dimethyl pentyne. Okay, I'm happy with that. Let's go to 2.3. So in 2.3, we're supposed to define the term functional isomer, right? So organic compounds with the same molecular formula but a different functional group. And then 2.3.2, write down the letters that represent these functional isomers. So in our context, in our curriculum, we only have two pairs of functional isomers. We have ketone, aldehyde, right? And then we have carboxylic acids and esters, right? These are the two pairs that we have which can work as functional isomers. So let's go back to our table and see what we can cook here. So compound A is an aldehyde, right? So if we have a functional isomer of that compound A, it should be a ketone with 4 carbons, right? As you can see, compound C is butanone. That is a ketone. So the answer to 2.3.2, we have A and C. Let's just verify that the question said letters. Okay, so letters that represent these functional isomers. So there we go. A and C are functional isomers. Let's move to 2.4. So 2.4.1. Compound F is formed when a carboxylic acid reacts with another organic compound X. So compound F, we have drawn compound F. So let's just copy it because we're gonna need it there. Copy, and then let's see if we can paste that. Okay. Can I paste? Having some difficulties here. Okay, there we go. That is compound F, right? I don't know what that is. Let me. Okay, this is just a mess. Is this compound F? Okay, this is compound F. Let's just carry on with compound F like that. So that is compound F. So compound F is formed when a carboxylic acid reacts with another organic compound X. Oh, X is not here on the table, it's just an unknown organic compound, right? So 2.4.1, name or formula of catalyst used. Obviously H2SO4, right? Or sulfuric acid, because this is an ester. If it is formed from a carboxylic acid, it has to be reacting with alcohol. And then 2.4.2, in the presence of sulfuric acid. A type of reaction, esterification. Esterification. Yeah, other people will say condensation, which is, I've seen in previous memos, should be fine, but it's esterification. Okay, 2.4.3, structural formula of compound F. So compound F is the carboxylic acid that is used, right? Compound F is the carboxylic acid that is used. Oh no, compound F is actually these which we have here, which we have drawn. So just to be more clean with my presentation, we just need to add hydrogens everywhere else. We have the answer to the question, really. So there we go. That is compound F. And then 2.4.4, IUPAC name of compound X. So carboxylic acid reacts with a compound X. So the compound X must be the alcohol. So let me put a line here, right? So not there, but here rather. So this part should come from the alcohol, and then this part should come from the acid. So the alcohol has 3 carbons. So what should be the IUPAC name of that alcohol? Let me know in the comments. Here we go.